So with that, we're going to transition over to the next aspect of our presentation this morning. And I want to introduce Subhash Jaini, who leads our Innovative Data Solutions group. He's been with Kiter for just a few months, but he's already brought a ton of energy and enthusiasm. And I think this is an interesting topic that you guys will enjoy. So Subhash, I'm going to turn it over to you. Thank you.
All righty. I'm Subhash, and I was brought on to Kiter to start this division up. And for two main reasons, this synergy happened. Y'all are focused on, Kiter's focused on business value and CPAs, COOs, CFOs. We care about money. And I feel like data science, in order for it to really thrive in today's business, people should care about business value. And then the other thing is people are curious about data science. So why not answer their questions if we can get the expertise? All right, so I'm going to jump right into it. When you Google definition of data science, it is still really a fluid definition. It's not something where we have certifications, even degrees. But one thing we can all agree on is the purpose of data science is to solve business value problems with data-driven solutions. Data-driven solutions, I'm going to talk about just a little bit because the idea of this presentation is to kind of bring data science to life and have people understand what it really means. So data-driven means that you can scope out a project and it may change on you. It may change at the 11th hour because you may find a higher business value pivoting and solving another problem near the end. It also means you may not get the results you want. People always say, well, there's a saying that crashes statistics and makes it kind of like you can make your story. If you do data science correctly, you really cannot make up a story. You pretty much have to go with what the data is telling you to do, or pivot and go after another direction, because data-driven really does mean, again, solutions and everything is based on data. The unique thing about data science also that differentiates it from general consulting is that we touch code, we touch computers, RAM, processing. We also touch statistics, probability, and sometimes mathematics. And then we also combine that. We as data scientists combine this with business expertise. The business expertise, I will say, in Silicon Valley typically gets a little lost. But in general, the subject matter expertise, the domain expertise is really what makes that final touch. For example, in a crane company, in crane operations, tower cranes, there's a need for site visibility. When the people of Silicon Valley figure out, okay, how are we going to address this? They add 500 cameras to it, the job site, and make it kind of like, in theory, we can track everything. They track everything, they adjust the data. Now there's 500, every second there's 500 video feeds going into this system. Well, they miss the business aspect sometimes, because from the business standpoint, all you need is one camera and you can interpret that data from it. So that's missing out on business. Now I'm going to tell you it's the scenario where people focus on the computer science side and the business and forget the statistics. So in a logistics company, they want to solve a problem of car accidents, and they're trying to predict when car accidents happen. So from a computer science standpoint, you can make rules that essentially you think are the best, and the business can get together and you guys can just not really look at the data, just make a hard-coded rule and say, if you go in these conditions, you're going to have a car accident. If you drive fast, you're going to have a car accident. Because they're not adding probability into this, they're forgetting the fact that if car accidents truly happen at these two rules, you could actually automatically remove car accidents in general for people. It doesn't work that way. We have people, we have probability. And I think that's why that initial system failed, is because they didn't account for human error. Humans do stuff. You never really know what they do, which at the end of this spiel of how data science, the workmanship of data science, the path, the workflow, I'm going to mention when we get into fraud, that's some fun human activity. So then let's say, for example, you get statistics. I love me some statistics and I love me some data, some business data. We get together and we neglect computer science. Well, then we have really great solutions. But sometimes they're not so great because it can't be implemented, or you can't pull the data daily. So on a scenario where you have to predict if the event is going to happen that will save lives for organ transplantation, let's say you just have business and statistics, you are going to come up with really great solutions that are statistically significant, but you might not be even able to pull that data because at that time, you actually don't know certain variables, or you put them, there's nowhere to place the model in the system, so it has to be standalone. So it's not useful. So you need all three to make data science work. You need to combine all three, and that's the magic of it. So now that we've gotten over some data science, what you want to be missing and why it's important, I'm going to go over the work of what we do. So in this case, we use something called crisp VM, and typically there's a if you look at Scrum, or even Scrum's better about reiteration, but in project management, there's something called crisp VM that it's a data science project management methodology. So I'm going to go over it, and before we go over it, we're going to do a code word. Code word 680. Yay! Hopefully everybody's like, what is this? Scrum? I've heard of project man. I've never heard of crisp VM. The number is 680. As you guys get to be, maybe y'all are Googling it right now, crisp VM. You're like, what is this thing? It's food. All right, so are we good? Okay, here's what it is. It's project management. And I'm circling the blue line in the presentation is where we're going to be talking about one at a time. At a high level, this thing reiterates like crazy because in real data science, you're data driven. Sometimes you might bounce back just because it's not achievable. Sometimes it's because it's not practical. Sometimes you have politics involved where your business user doesn't want to expose data for security purposes. Sometimes you have a scenario where they don't want to because of privacy data. Sometimes you don't want to have that's just on the political side. Sometimes you don't want to have, the business user doesn't want their data to be anywhere else other than their own system. Sometimes it's financial. Sometimes it doesn't make sense to onboard the data because it's too expensive. So that's the flow. But in the business understanding, we're really trying to figure out what is the problem. And this, man, sometimes it takes you weeks to find out what the problem is. You're brainstorming, you come up with ideas. Harvard Business Review is not it seems to be that what gets people interested in it, but just because you're in the same industry as Harvard Business Review and that you read an article, it may be totally irrelevant. It may actually work perfectly for you. You may even have a business problem that your peer company has recommended because y'all both use a certain system, whether it's a CRM or financial system or even a tool for like field logistics. But because the way they use it is different and because the implications are different, then it won't work for you. And the focus on the business understanding phase is really to not necessarily get into the data part, which is the next step. Your first focus is just to care about business. And it always drives into two big things in this section. It's how to make more money and how to save yourself some money. So either affecting costs or affected revenue is really where, to speak CPA, really your revenue and COGS. So in this, really important step. If somebody wants to do something because it's interesting, this is where it still technically is data science, but I would shy away from it, and many others in my industry would as well. So I'm not the only, I know I'm being more focused on business as a data scientist is kind of sometimes rare, but really the reason why you want to have business value is because you want this thing to go in production. You want people to be using it daily and you want it to optimize. So business understanding is really important. After you get into business understanding, you got to get into data understanding. Honestly, this requires data access. You might actually have to go back to business understanding because you realize you can't access something or it's too much of a hurdle to learn the data. It's a big lift to be able to tackle this step. However, the neat part about this is if you go through this part as a data scientist, you will actually learn things that make you a better expert in the business you're helping. So if I'm a data scientist employee in your organization and I go through this phase with you, I may realize, ooh, we might be able to help because I just went through the business phase. We might be able to help this unit instead of that unit. Or this division and this division have the same business problem because they use the same data system, and we can start going back. So you might end up going back to business understanding to really get the idea of really get that really good idea to solve. Then you get a data preparation. So data preparation is honestly the most of the data science work. It's boring, it's tedious. Sometimes you have to make scripts to clean the data. Sometimes it's scripts to pull the data out. Sometimes you're making programs that take you 2 days and add no business value. So this is a sad part. Some people live for it. I mean, in data science, there's a bunch of different, before I finish this presentation, I'm going to explain all the disciplines within it. There's a discipline with every single one of these steps. In some cases, there's multiple disciplines. And in data preparation, there's whole careers for people moving data from point A to point B, moving it back to point A, and then also prepping it for a model. Now, prepping it for a model it starts getting exciting because when you start prepping the data for a model or the real thing, we're calling a model, even if it's not a predictive model. It could be an optimization model. It could be a survival model. It could be a visualization model. It could be an actual like an algorithmic model that's just a pure calculation. Whatever it is, by the time you get this data preparation, before you exit this phase, you need to be ready to model. Like it needs to be model ready. So you get it there and you can do some preliminary stuff. Usually every modeling methodology has default parameters and you can just run it. But that's the end. The end is really exciting. The modeling is something I could have a whole class about. Modeling is fun, it's dynamic. You have a target and you have predictors. In machine learning models, that's predictive. In optimization models, you have a target and you have constraints. So you have a goal such that certain constraints are hit. In visualization model, you have the metrics that people are really going after, and then you have the stuff you have to work with it. In a survival model, you have your data that is the results on the same level as the data that is the scenario given. So that way you can combine it. And again, I'm saving the actual evaluation and the magic to the next step, because at this point you're just doing basic modeling and you're seeing, okay, if this model exists, what do I do with it? If it exists, what do I do with it is got to be your number one question. Even sometimes if you're really brand new to data science, a data scientist might ask you, I have the model today, what's your plans with it? So going back to business understanding, because this is a very circular process. If they don't know this right now, if it's just for them to know, well, then maybe it shouldn't even get to the next phase. So anyway, in modeling, I will honestly say though, that sometimes when people have an actual model and they can see the results, they'll realize like for example, we were predicting when a customer was going to not show up to a doctor visit. So we had the model. In this business understanding, we found out that that was the most important detail. Data understanding, we had access, it had to be one-off, so they gave us the subset and we were able to implement later. The data prep was relatively easy, but in the modeling, we got there, we got the model, it was like 89% accurate in detecting who's not going to show up that day. But we actually found out in an evaluation, it did real well. Which evaluation, you're just evaluating it, seeing what it's going to do. But on the next phase of evaluation, you're trying to figure out you're trying to confirm the business value. You're applying the logic. We found out that it's irrelevant. It's actually at time of schedule that knowing somebody not showing up is most important. There was another scenario where in the modeling process where we found out we could predict how to increase somebody's performance with certain metrics that are changeable in order to, for a bonus structure. So like a company in the ag space was trying to figure out how to hand out bonuses, and their business problem had very much good value. They wanted to figure out how to pay people so they don't leave, and then pay people so they feel like there's equity or equality. Big areas that sell a lot of this cow supply are always going to be selling a lot, and small areas that sell a little are always going to be selling a little, regardless of the manager itself. So in the modeling phase, we actually found out we could do additional wins by telling them, okay, we've already got your data. We know which people might be good candidates for getting raises, but the predictors themselves were more important. So we were able to predict which customers are likely to leave. And that ended up being so at the end, we're talking at the end of this evaluation, we found that there was a bigger win. So that's where you want to go. So when you do data science, you're kind of committing to that being dynamic and committing to be able to solve these problems, because again, when you get to these phases, you never know what's going to happen. There's another company dealing with so back to data preparation, and I know I'm bouncing around, but in this space, just to kind of confirm one last evaluation thing, there was a company that does parties and events, and we flew right through just jumped instantly to modeling, because they had their data together. They do one-on-one events, and they already had a model in place. So I assumed that I could just make a new model to do group-to-group matches, because they currently have one-to-one matches. You sign up for this app, it's like a dating app for business networking. So you assume it, but then when you dive into the data, you realize, wait a minute, they have nothing. We actually are at the modeling phase. We've built them what they want, and we've had to go back to the data understanding to really figure out what makes a meeting exciting. And it's always a lot harder to do that when the business side is focused on the results that they want to see. Because modeling, everybody wants to see the results. Okay, so that's the last spiel of on modeling and evaluation. They go hand in hand. You model, you evaluate. You model, you evaluate. Back and forth. And in practice, this is where your business value happens. Then after you get business value out of it on a one-off, deployment comes into play. And deployment is on a daily basis, how can you make this thing run? On the matching case, when a match happens, how do you group people in the table? And in deployment, you may find other nuances, like, for example, this is why I mentioned the matching. Because when you have table settings, you know that theoretically, when people sign up to events, you can theoretically group everybody in tables. But in practice, when you're actually at the event and you're deploying this algorithm, there's people that don't show up. So now you either need to have a predictive model of people not showing up and put them all on the same table, or you have to have the algorithm run at the point of everybody's there. You also have different dietary restrictions that many places handle it well, but if you could kind of add that bias into the model, that would help, but they didn't think about that. until they actually went to an event and saw like one or two people everywhere needing a specific meal. It would be nicer to have them all together because that would have been a better conversation. So in deploying the app, they knew what they wanted, but they still needed those changes, which is why it goes, if you notice, it goes back to business understanding. So if you deploy the networking app to get people together, it would bring you back to, after we finish that, after us data scientists do your work to make that matching work, we're going to need another predictive model, which will push you back to the business understanding. Now you have a predictive model who's not going to show. Now you also can add the dietary restrictions back to the model. Continuous improvement. So to be data-driven is like, I wanted to bring that to life because I went back and forth in these slides, and that is how data science is. But in the end, you have products that are superior that you can't actually create by just saying, give me these four, make this app do these four things. And this is exactly what I want. And I can have you do it or anybody else develop it. It's all, it's all the same. Data science isn't like that. Data science is so special that you have to use your customer data, your revenue, your vision, your biases of how you run your business. Two logistics companies, again, one could be predicting crashes, the other could be predicting crashes for certain scenarios, and your data could be the same, but it would run completely different because one may be paying out a lot of money on crashes, the other may not have that much of a consequence because of its liability and on their actual business side. Two same companies, same data source. All I'm saying is that data science is dynamic, but it's also really fun, and you get to make products that are just really will change the DNA of your company. So it's really fun. So I know I talked very long, sorry. I'm gonna go over just fraud detection, which is, it'll lead us into this next section, but think of it this way. Fraud detection is complicated because it's a really rare event. So statistically speaking, it's hard to detect. These are all the options to just deal with that problem. But the reason why it's not just a rare event and fraud is different, and this is where the business side needs to weigh in more than the statistics side. So a statistics person says, wow, it's a really rare event. Let's predict this fraud. Give me the data set that gives a scenario that would cause fraud. So you have, think of each row as a person or an event and a person. So you're dealing with time of day because maybe you're just trying to detect when the fraud happens. And you have data sets where the person was flagged as, or the activity is marked as fraud. Fraud actually has malicious intent. So unlike a plane crash, when a crash happens, the pilot doesn't want to intentionally crash the plane. Or when somebody is diagnosed with cancer, out of all those times, it's a rare event, but people don't actively try to get that. Whereas fraud, people are maliciously trying to be avoided. It can happen one or two or three times and then not happen and then continue to happen again with that same person, same behavior. It's also got some other mathematical phenomena. So anyway, this is just data science addressing fraud detection. So you could sample differently. And again, these might be, you might just want to reference later, but sampling means you pull data out, compare the rare event versus the common event, and you make the rare events more common, but you do it intelligently. That's the cool thing about SMOTE. Typically a predictive model deals with AUC, which is an accuracy metric. There's other metrics called recall and precision, which those are whole discussions on their own, but open your eyes to what is a success. Is a success catching every person who's committed fraud? Because then I could tell you, I could make a model for that right now. Everybody's committing fraud. So if you say that, you're 100% accurate. But then you could also say, well, I want the best area under the curve. Well, then it's generally going to be biased towards saying nobody's creating fraud. You want that dance to say, I want to know out of how many attempts, how many am I getting right? And again, success metrics is a whole conversation, especially when we start talking about profitability and lifelong value of a customer and all that fun jazz. Also in fraud, in predictive models, you want to be able to take all data and push it into a model. In fraud, you could actually make a model that says, let's make a model to see who's even likely to have fraud. And then of the subset that is likely to have fraud, push them through another model. So you could do that, or have a rule of thumb to say certain people who hit this criteria are likely to be fraudulent. Let's model for them and go with that. Build a cluster that indicates fraud. Cluster analysis is really common in fraud. And it's kind of like we had to do this for resumes to detect if somebody was lying on a resume. And luckily there's rich data sources for that, but it involves, oh, actually it's bag of words. So if you jump to number 7, looking at the text of the wording of how they do it is kind of going to be similar than people who are telling the truth. So not financial reporting fraud, but another type of fraud that's hard to catch. Also, you could tell nearest neighbors. So if there's certain scenarios where these are fraudulent, you can just say, let's give other scenarios that are similarly fraudulent. And again, bootstrap sampling is mentioned. It's a whole thing. It's really is a whole thing to just, and I'm definitely about to jump into the code word. And with that, are there any questions dealing with fraud on the technical side, data science, anything like that? No. Okay, no questions. Then we will end this presentation with code word 501. All right, and now it's intermission time. Now you can all dream about data science while you eat. Thank you.